Hey guys, welcome back to our third video using the unit circle or filling it out. I told you we'd spend a lot of time on the unit circle because it is very important. Today we're going to focus on these blanks that look like coordinate points. Like I should have a value like 1, 3, or over here like -2, 4. And that's pretty much what it's going to be, except we're going to have a little bit more specific of answers. Okay, I'm going to concentrate on the first quadrant in this video, and then we'll extend that and look for patterns later on in quadrant 2, 3, and 4. So in order to fill out these blanks, it's actually it's a blank that means trigonometric functions. And there's two in particular we're going to use. The first blank stands for the cosine of theta, and the second blank stands for the sine of theta. And remember, we've seen theta once already before in this video. Theta always stands for the reference angle. So my theta equals rough angle, the reference angle. And actually this theta stands for that as well. So you will have to find the reference angles for certain degrees and use that to find the sine and cosine. Okay, which is why we went over that earlier last week. All right, so let's start with just the first quadrant. We have 1, 2, 3, 4, 5 coordinate points we're going to fill out. This guy is pretty easy here. Okay, if you think about just a normal XY coordinate grid, like say I put some marks in here, and if I have a point that goes out 1, and this is always weird, maybe. Well, let me write out 1, there we go. And I don't move up or down, that would be the point 1, 0. Well, that's exactly what this point is. Okay, we have actually a unit circle. The radius is 1, so I could draw the circle in. Okay, really tiny here, but ours is like blown up. So from the center out, that radius is 1, hence why this value here is 1, and the second value is 0. And I'm using green and pink specifically because I had the cosine value green up here and the sine value pink. I'm going to do that around the whole unit circle. Our first one's pretty straightforward, okay? So let's look at a little more difficult one, like the 30 degrees. And this is going to bring a lot of the stuff we've done from previous units together here. It's great how this all comes together. What I'm going to do is I'm going to create a right triangle. Okay, that's actually what this whole unit circle is about right triangles. And when I say 30 degrees here, I really mean like this is actually where the 30 degrees is. It's tucked down in there. It's the reference angle, which is why I drew the reference angle in there in the last couple of videos. So right now I have a 30 degree, a 90 degree. I'm missing this angle, which some of you might know what it's going to have to be. 30 plus 90 plus what will give me 180, and that would be, oh my God, 60 degrees. So I have a 30, 60, 90 special right triangle, and special right triangles have certain relationships on the sides. We did this last semester. That relationship is if I go to the short or the smallest degree, which is 30, and I go to the side opposite that, that's called our short leg, or we gave it a value of A. If I go to the 60 degrees and go across from that, that is a value of A times square root of 3. And if I go to the hypotenuse, so from the right angle across, in a special right triangle for 30, 60, 90, that is 2A. So hopefully you kind of recognize this reference triangle for 30, 60, 90 from last semester. If not, well, here it is, and you got to know it now. But we're going to concentrate on all the coefficients, like the 2, the square root of 3, and here the coefficient would be 1. So that means I'm actually just going to erase these A's. Whoops. This erase the square. So it's square root of 3, that one's 2, and this is a 1. That's what we're going to focus on. Now, to find this coordinate point, remember it's the cosine and then the sine. Let me write that out for you guys. I need to find the cosine of our angle, which is 30 degrees. Okay, well, how the heck do I find that? We have to use our good old friend SOHCAHTOA. Like I said, lots of things coming back to us we got to use. Where we can say the cosine is, oh my God, I just spelled it wrong. There's an H in here. That would be helpful. Ka, and then toa. There we go. So the cosine is going to be the A over the H, which is the adjacent over the hypotenuse. Well, we got to label which ones are the A, the H, and the O. Okay, so across from 30 degrees, that would be my opposite, my O. I'll put an OPP. Right next to the 30 degrees, that would be my adjacent, ADJ. And across from the right angle, that's our hypotenuse. Okay, that's going to be super helpful for this. So cosine again in SOHCAHTOA is A over H. Okay, well, my A value here is square root of 3 over my H is 2. So cosine of 30 degrees is square root of 3 over 2. Let's take a look at the sine of 30 degrees. Okay, sine is O over H. Well, my O is 1. My H is 2. So sine of 30 degrees is a half. And if you're not already, you guys, I would write all this extra stuff down, maybe on a different piece of paper. Okay, it's going to be important to have. This kind of gets really messy. It's okay to do this first one right on the unit circle, but I will erase this and make a bunch of other ones. You may just want to have a separate piece of paper to do all that. So anyways, if I transfer this, the cosine of 30 degrees, that's this first blank, is, let me zoom in if I can, square root of 3 over 2. And the sine is a half. So this coordinate point is square root of 3 over 2, comma, a half. And we always want it in fraction form, not decimal. It's a proper way for the unit circle. Moving along here, we now have 45 degrees. So I will do this off to the side like I told you guys you should, just so I don't have to erase this. I'm going to have a 45, so from the 0 degrees up to the 45 degrees. I'm going to make my right triangle. And remember that 45 is really just referring to this angle tucked in here. So I have a 45, 90, and then this would also have to be 45 degrees. Let me zoom in actually. And I have a 45, 45, 90 triangle. Well, if you remember from our reference triangle, the two legs that create the right angle or create the L, those are both A. And then across in the right angle, it was A square root of 2. So again, for the sake of this, I'm just going to use the coefficients. So it'd be 1, 1, square root of 2. So I'm going to erase the A's. I don't need those. So my goal now is to find the cosine of 45 degrees and then the sine of 45 degrees. And if you would like, write down the SOHCAHTOA to help us. And don't misspell it like I did the first time. Cosine is A over H. Okay, so I'm using this 45 degrees here. Across from that, this would be my O. Right next to that would be my A. And then over here would be the H along the side. So cosine is A over H. A is 1. H is square root of 2. I will leave it like that for a second. Let's find the sine of 45 degrees. Okay, sine is O over H. The O is 1. The H is square root of 2. So they end up being the same thing. However, we do not and we cannot have square roots in the denominator. So I have to rationalize that by multiplying by square root of 2 over 2. So the numerator gives me 1 times square root of 2, which is just square root of 2. Denominator, square root of 2 times square root of 2 is just 2. So that is a better answer. Cosine 45 is square root of 2 over 2. Now, since these were the same thing, I would rationalize it, but I would end up getting the same thing, which is just square root of 2 over 2. So let's go back to our unit circle and fill in our cosine and our sine. They were both the same thing. Cosine is square root of 2 over 2. And the sine was also, oh, I wrote these in the wrong color. Just a second. Square root of 2 over 2. And square root of 2 over 2. All right, 60 degrees. Let's draw a 60-degree triangle over here. Okay, this is our 0 degrees, and this was the 60 degrees. I'm going to create a right triangle, and that 60 actually means it's tucked away right here. Okay, and so that means this one is 30. Okay, we already talked about what these sides are for the reference triangle, so I'm just going to write those in. Across from the short side is 1. Across from the 60 degrees is square root of 3. And the hypotenuse is 2. And while I'm at it, I might as well label my opposite, my adjacent, and my hypotenuse. So again, I'm going to find the cosine of 60 degrees and the sine of 60 degrees. Cosine is, in SOHCAHTOA, the A over the H. So my A is 1, my H is 2. The sine of 60 degrees is O, which is square root of 3, over H, which is 2. Those are okay just like that. No radicals in the denominator, so I will copy those right over here. Cosine of 60 is 1/2. 1/2. And I just found the sine of 60 was square root of 3 over 2. I'm going to take a second and pause this video and stop it here, and we will continue the rest in the next video.